Okay, so real talk. Most of us have absolutely no idea what's inside a lipstick. And honestly, maybe we don't want to know, because the answer involves animal wax, oil blends, and pigment powders being crushed between industrial rollers. But here we are. And before we get started, I know what you're thinking. Do I actually use lipstick? Great question. I'll answer that at the end of the video. For now, let's get into the factory. A lipstick isn't just colored wax shoved into a tube, although honestly, that's kind of what it is. It's a very specific blend of different waxes, oils, and pigments that all have to work together perfectly to give you something that glides on smoothly, holds its color, doesn't melt in your bag on a hot day, and actually feels comfortable on your lips for hours. 3 main waxes go into most lipsticks. Carnauba wax, which comes from the leaves of a Brazilian palm tree and is also used to polish cars, which is a fun fact nobody asked for, gives the lipstick its firmness and stops it from turning into a waxy puddle the moment temperatures rise. Beeswax adds flexibility and that smooth glide. Candelilla wax holds everything together as a binder. Then a whole range of oils go in alongside the waxes: castor oil, jojoba oil, vitamin E, which give the lipstick its moisturizing feel and make it actually pleasant to wear rather than feeling like you've smeared a candle on your face. The balance between wax and oil content determines everything about the final texture. More wax means firmer and more matte. More oil means softer and glossier. Getting that balance right is genuinely one of the most technically demanding parts of making a lipstick, and it's exactly why cheap lipsticks feel so different from expensive ones. Once the formula is locked in and all raw materials have passed quality checks, production starts with melting. The waxes go into large, heated mixing vessels, big jacketed tanks that maintain precise temperature throughout the whole process. Different waxes melt at different temperatures, so they go in one at a time in a specific order, starting with the highest melting point ones first. Once everything is fully melted and combined, the oils get blended in gradually while the mixture keeps getting stirred continuously. Temperature control here is non-negotiable. Too hot and certain ingredients break down and the color shifts. Too cool and the waxes start solidifying before everything is properly combined. The machines keep the temperature locked in a very tight range the entire time, a level of care that honestly puts most home cooks to shame. With the base fully prepared, pigments go in next, and this is where the lipstick actually gets its color. Pigments arrive at the factory as dry powders: iron oxides for reds and browns, ultramarines for purples and blues, titanium dioxide for white and opacity. But here's the problem. You cannot just throw dry powder into a wax melt and expect smooth, even color. The pigment particles clump together, and you end up with streaky, patchy results that look nothing like what the shade is supposed to be. So the pigments first get mixed into a small amount of oil to create a dispersion, and then that dispersion goes through a 3-roll mill, a machine with heavy rollers that crush the pigment particles down to microscopic size and distribute them evenly through the mixture. This milling stage is what separates a lipstick that gives you smooth, consistent color from one that goes on patchy and uneven. It is genuinely satisfying to watch in a way that is very hard to explain. After milling, fragrance, preservatives, and any remaining specialty ingredients are blended in to finish the formula completely. Before a single tube gets filled, the entire batch gets tested. Color gets checked against the approved shade standard under controlled lighting. Texture and consistency get evaluated. Safety checks confirm everything is performing correctly. Any batch that doesn't match gets adjusted or rejected entirely. The factory is not sending out a red lipstick that shows up orange on your lips. That is simply not happening on their watch. Then comes molding, the stage where the lipstick takes its actual physical shape. The approved melt gets transferred into temperature-controlled holding tanks that keep it perfectly fluid. From there, it gets poured into metal molds in the exact shape of that familiar tapered bullet. The molds are chilled so the lipstick solidifies quickly as the hot melt contacts the cool metal surface. But cooling has to happen at a controlled rate. Too fast and internal stresses develop that cause cracking. Too slow and the bullet doesn't release cleanly from the mold. When the timing is right, molds open and out come perfectly formed lipstick bullets, solid, smooth, and already looking like something you'd see on a store display. Every single bullet then gets visually inspected for surface defects, air bubbles, cracks, and color consistency. Anything that doesn't look right gets melted back down and remolded. Nothing moves forward unless it's perfect. Bullets that pass inspection get loaded into their tubes.
the twist-up mechanism that extends and retracts the lipstick. This loading has to be precise, because if the bullet isn't seated and centered correctly, the whole thing wobbles when you twist it and feels cheap in your hand. Nobody is paying good money for a wobbly lipstick. Automated equipment handles the loading at speed while keeping alignment tight throughout.
Now, here's the part that genuinely surprises people. After loading, every single lipstick goes through a flaming process. Each tube gets briefly passed through a flame or under a radiant heat source that melts the absolute outermost surface of the bullet, just enough to smooth out tiny imperfections left from molding and give the lipstick that perfectly glossy, flawless finish you see when you first twist one open. It happens fast, it's subtle, but it makes a noticeable difference to the final appearance. After flimming, one last quality check covers color accuracy, surface finish, twist mechanism smoothness, fill height, and overall appearance. Only after clearing all of that does the cap go on.
Capping machines press the outer cap onto each tube, and everything moves into packaging. Each tube goes into its branded outer box, carrying the shade name, ingredients list, and all the regulatory information needed to legally sit on a shelf. Packaging lines run fast. Finished products get grouped into display boxes and shipping cartons, palletized and sent to the warehouse, ready for distribution.
From wax blocks and pigment powders to a finished capped packaged lipstick, the whole process involves precision blending, temperature management, industrial milling, controlled molding, flaming, and multiple rounds of quality inspection. That tiny tube that gets pulled out of a bag and applied in about 4 seconds is the result of a manufacturing process that runs with more precision than most people would ever associate with a cosmetic product. Simple on the outside, seriously engineered on the inside.
And now, the answer I promised you at the very beginning. Do I use lipstick? Honestly, no. I don't need it. I'm already beautiful, so why bother? But you should absolutely subscribe to this channel. Not for me, for the knowledge. Because clearly you're the kind of person who watches a video about how lipstick is made just to understand the world better. And that is exactly the energy we love here. Subscribe, hit the like button, share this with someone who owns more lipsticks than they can count, and we'll see you in the next one.